Hello everybody. In this video we're going to create a program that allows the user to enter 3 test grades and then it'll calculate the average. And another thing it will do is if the user has a perfect average, then it will congratulate them. If they don't have a perfect average, then it'll give them a message telling them, to work harder. And then at the end of the program, it will also determine their letter grade. So if they have a grade between 90 and 100, then they get an A. If they get a grade between 80 and 89, they get a B. 70 to 79, a C. 60 to 69, a D. And anything lower than a 60 will be an F. Alright? So let's go ahead and get started on this project. Okay. So I'm here in Linux in the terminal. So I'm going to do ls. And I'm going to go to my Video Labs folder. Alright. And then I'm going to see what I have here. Okay, so I have the first 2 programs we've done. So I'm going to create another folder. And that folder will be for our program here for the grades. So I'm just going to call it grades. I'm going to switch directories, CD. And then I'm going to go to the grades folder. And I'm going to use nano. I'm going to create a source.c file. Now remember, when you're turning in your work, you want to make sure you're always turning in this source.c file, because this is where your source code is going to be. Whenever we compile a program with a code and then make a executable program, that program, do not turn it into me, because I can't open it, I can't grade it. So just turn in the source code so I can read your code. Okay, so I'm in the folder here. So then I'm going to do my template here, include stdio.h, and then I'm going to do int main for the main function. Every program must have a main, and I will return 0. Okay, and semicolon. Okay, so in order for us to build this application to calculate the average of 3 test grades, we're going to need to declare some variables. Okay, so let's go ahead and declare some doubles for our grades. So grade 1, comma grade 2, comma, comma grade 3, and comma average, and then a semicolon. Alright, so we'll have those 3 variables to hold our information. So we're going to have to next ask the user for 3 grades and obtain them, right? That's just because we asked doesn't mean that we're actually saving them. So for our prompt, we're going to use printf. Then we'll type out the first one. So enter grade 1. Semicolon. And then here, remember, we're going to use scanf. And then these are floats, so we'll use our conversion specifier of %f. And then you must get the address of grade 1. Okay. So that's for the first grade. Now we gotta do grade 2. So then enter grade 2. And then scanf. %f. Same thing again, except this time we're going to do it for grade 2. Semicolon. And then we got to do grade 3. Printf. Enter grade 2, 3. Right. And then we'll do scanf. And then %f. And then the address of grade 3. Semicolon. Okay. So now that we've asked the user, let me update this comment here. we've asked the user for 3 grades and obtain them. And then the next thing, I'm going to use the arrow key to go down. So then the next thing I'm going to need to do is calculate the average. So to calculate the average, I'm going to do average equals, and then I'm going to do, you have to use the order of operations. So let me write that here real quick. So here, calculate average. Remember the order of operations. You can remember it as PEMDAS. So whenever you're evaluating arithmetic expressions, you got to use the order of operations. So the first things that are evaluated are going to be the parentheses, then the exponents, then multiplication, division, and then addition and subtraction from left to right. Okay. So that's important here in this particular problem. Let me show you why. So I'm going to do grade 1 plus, so remember to do the average, you add them all up, get the sum, and then you divide by the number of items. So grade 2 plus grade 3 divided by, and you'll do 3.0, semicolon. Now, the problem here is that we're expecting that grade 1, grade 2, and grade 3 are added together before we divide by 3.0. But based on the order of operations, since we don't have any parentheses, then the order of precedence says that we're going to do division first. So then I'm going to divide grade 3 by 3.0, and then after I divide them, then I'm going to end up adding grade 1 and grade 2, which is going to give us completely the wrong answer. So that's why the parentheses are very important in this particular problem. So you got to make sure you do the parentheses, follow the order of operations, so then we'll get the sum of grade 1 plus grade 2 plus grade 3, and then we'll divide it by 3.0. Okay? So then once you have your average, then we can go ahead and display it. So I'm going to do print f, and then I'm going to do something like this, average. I can do a colon, and I'm going to do a %f, and then here you can separate the arguments using commas. In fact, you could do something like this, where you could list all the grades. Let's just say you wanted to do that. So let's say you do grades. So I'll show you something here. So that's going to be %f, comma, %f, comma, %f, comma. So something like this. So let's say you want to relist all the grades, and you want to list out the average. So now I have 4 format specifiers. All of them are floats. So then here I can separate each one by a comma. So for the first placeholder here, I'm going to do grade 1, and then the second one grade 2, and then grade 3, and then the last one's going to be average. So then you got to put them in order now. So here it's trying to show you that for the output you can display more than one thing, and then you can just separate it by commas. Alright, so printf is pretty cool for that. Also, don't forget your new line operator. So we'll make sure we'll do a new line. So like this, escape sequence, new line. And then here you just want to make a note for yourself what's going on. I'll do something like display all the grades and average. Okay. Alright, so that looks pretty good. Let's go ahead and do Control O to write it, Control X to exit, and let's go ahead and compile it. Hopefully it works. So then we'll do GCC, then we'll do source.c, and then our output program here is going to be, we'll just call it program. Okay, so no errors, so everything should be good. Let's go ahead and run it. So ./program. Then press enter. Then I'll just throw in some grades, some bad grades. All right. So notice here it displays all the grades, and then it displays the average at the end. All right, so that looks pretty good. You may want to round off a little bit. So let me show you how to do that. We did it last week, but we'll do it again. So here you got to make sure you put on the format specifier, you got to put .2, .2, .2, and then .2. Okay, so then I'm going to Control O, exit. Every time you make a change, you got to recompile. Okay, so then let's do some new ones. Alright, so now it's all rounded off. Only shows 2 decimal places, and then it has the average here. So pretty neat. Alright, so we're going to go clear that. And then the next thing we're going to do is we're going to check to see, using a conditional statement and a decision structure called an if statement, or actually if else. We're going to use if else to check to see if the grade is a perfect, or the average is perfect by being at 100 or higher. If it's perfect, then we'll display a congratulations message. If it's not perfect, then we will display a different message. Alright, so we'll go ahead and try that next. Okay, so let's go back to our code here. I'm going to do nano.source.c. Alright. Now the next thing we're going to do, here at the bottom, put some space, hit tab, and then I'm going to congratulate. That's one of the words I can never really spell right, but yeah, it's good enough. Congratulate the user if they have an average of 100. Right? So how do we check to see if the average equals 100? Right? So for this, we're going to use a conditional statement called an if statement. So I'm going to do if, and then the syntax is going to be the word if, and then in parentheses, you want some sort of condition, right? Some sort of conditional expression statement. It's also called a relational statement. So we're going to type some sort of condition here. And if that condition is true, then we'll execute the code within the block. The block is going to be the code between the 2 brackets here. So make sure when you type your if statements that you always put your opening bracket and your closing bracket. So before I type the code, I want to know what is my condition. Your condition usually is a relational expression, and it uses some sort of relational operator such as less than, greater than or equal to, less than or equal to, or the not operator. It's not equal to. Right? So we'll see an example of that. So to check for equality, to check if something equals something else, what you're going to do is you're going to use the equality operator, which is 2 equal signs. And it's a binary operator, meaning that it has 2 operands. Right? So you're going to check average, and we're going to check to see if it's equal to 100. Okay. Now, you got to make sure, one of the most common mistakes that students make is that whenever they're checking for equality, that they put a single equal sign rather than a double equals. Okay, so a double equals, it checks for equality. A single equals is an assignment operator. 2 very different things. The assignment operator gets whatever's on the right, If it's a calculation, an expression, a value, numeric value, whatever it is, it gets whatever is on the right and assigns it to the variable on the left. That's all it does. It doesn't check to see if these two sides are equal or not. Here we are. If average equals 100, then this expression evaluates to true, and whenever the thing in the parentheses is true in an if statement, then it'll execute the code. If it's false, it won't do anything. Okay. So what we want to do is we want to print f, and we want to tell the user great job, perfect average. Now this message will only pop up if they have 100 average. If they have an average that's higher than 100, then that's something else. We'll take care of that another day. But this is just an example. Alright? So do Control O, save, enter, exit. And then I'm going to compile. Every time you make a change, you must compile your code. Now what we're going to do is we're going to run our program, but this time we're going to do all perfect grades. So 100, 100, 100. Okay. So it displays the grades. Then it congratulated the user, but then we forgot our new line, the escape sequence for /n. We forgot that, so we'll add that. I knew I forgot something. Right. So we'll go back here, and then we'll do /n. Okay. So this message only prints out if the average was 100. Watch. Let's see what happens if it's not 100. So make sure I'm going to compile real quick because I made a small change. And let's say it's not 100. It's not perfect. It's good, but not perfect. Right? Then it doesn't display anything. It does not display anything. Okay. So let's go back here to our code. And we could display some message. We could display something if it's not perfect. So let's see how to do that. So I'm going to go here. And remember, this is to check for equality. There's also a not operator like this. This is to check to see if it's not equal to 100. In this case, we're not doing that. But just so you know, it's there. So here we have either this is true or it's false. Okay. So it can't be true and false. You can't have an average of 100 and then not have an average of 100. It either is or it's not. It's either yes or no. So we call that a mutually exclusive test, right? Where two possibilities cannot occur. Only one possibility happens, but not the other. So if the first possibility didn't happen, this average is not 100, then we can use, on this if statement, we can use something called else. So if else. Okay. So if this is not true, then we're going to just execute this code instead. So if it's true, we print out 100. If it's not true, then we'll do whatever it says here on the else, in the else block from line 27 to line 29. So then here we'll just tell them something like try harder for perfect average. Okay. And then don't forget your /n. And it's got to go in the quotations. And then semicolon, right? So average not 100, then we'll skip this and we'll go straight to this. If it is, then we'll do this line and then we'll skip this one. So let's test it. Control O, enter, exit. And then we're going to recompile. And then let me run my program again. So let's say I had the same one before, 30, 100, 100. Not perfect. Then it tells the user, hey, try harder for perfect average. So it tells them that they didn't get it. And then we'll try one more time with a perfect average. And then now it does say perfect average, and it skipped this one. Right? So depending on the situation, depending on the condition, it either prints one message or it prints the other. Okay, so let me go ahead and clear that out. So then now that we have a basic understanding of if and else and doing if statements and making decisions in our programs, now it's time to make the decision of what is the letter grade. So we're going to do that next. Okay, so let's go back to our code. I'm going to do nano source.c. Then I'm going to go to the bottom here. And the next thing I want to do is determine the letter grade. The letter grade using if else if and else. Alright, so we'll talk about what this is in a little bit. Okay, so what we're going to do is we're going to create an if statement, and we're going to check to see if the average is greater than or equal to 90. If it is, then we're going to give the letter grade an A. If it's not greater than or equal to 90, then we're going to do an else if. So that's going to check a different condition, right? Is the average greater than or equal to 80? If it is, then we give a B. If it's not, then we check to see if the average is greater than or equal to 70. If it's not, then we move on to check to see if the average is greater than or equal to 60. If it is, then we give a D. If not, then there's no other option, right? We've gone through every single letter grade and none of them match. So the only other option is to assume that the average is less than 60, less than 60. And so then we just give an F, a letter F. Now, how are we going to store the letter grade? Remember, so the only data type we've really worked with so far is integer and floats. So let's go back up here to the very top, and you want to keep your variables all in the same place. So here I'm going to declare what's called a char, or a single character, and I'm going to call it letter grade. So this is going to store if the letter grade is an A, an F, a B, whatever it is. So now I have a variable for that. Okay. So we're going to do if. So we got to check our first condition. Our first condition is if average is greater than or equal to 90. So that counts for if it's 100, 102, if it's 91. Anything above or equal to 90 is an A. Okay, we're used to that already. So then remember your if statements, you got to have your curly brackets, your opening and closing ones. Make sure you type them at the same time, because if you don't and you lose one, then trying to find where the closing or the opening bracket's supposed to be is going to be really challenging. And so that's why I always type them together at the same time, because they always come in pairs no matter what. So might as well just type them both, and that way you don't lose track of them. All right. So if this condition is true, if the average is greater than or equal to 90, then I'm going to go ahead and set the letter grade equal to, and then in single quotes I'm going to put A, capital A. Now here, this is what we call a char literal. Char literals have to have single quotes. Okay. This is a string literal. So this is a combination of letters. String literals have double quotes. Char literals have single quotes. So always remember that. If you're working with a char, you got to use single quotes. And for char, you can only type one letter. If you try to type two letters, you'll get a syntax error. So strings have multiple letters and they have double quotes. Chars have single quotes. Okay. So we have our if statement. Now we're going to need our else if statement. So else if, and then we type with the condition. If the average is greater than or equal to 80, and then we type our brackets. Okay, so let me go and make some space here real quick. I'm going to go and press up, enter a few times. Alright. So we did our if. If this is not true, then it's going to jump to line 37 and then evaluate this expression. If this guy is true, then I'm going to do letter grade equals B, semicolon. Now, if that's not true either, then I still got to check other grades, right? If the average is greater than or equal to 70. I like to put spaces on everything, so I'm going to try to keep everything the same. Now, it is a syntax error if you do a semicolon here. Well, it's not a syntax error, I'm sorry, it's a logical error. So it'll still work, but it's not going to give you the right result. So please make sure never to put a semicolon after your conditional statement in an if. Because what happens is if you put a semicolon there, then it'll skip the entire block. It'll skip everything from line 42 to 44 if you put a semicolon here. So I'm going to do letter grade equals single quote C, semicolon. Okay, so and then we got to check for the 60s. Average greater than or equal to 60. Remember, always type them at the same time. Then I'm going to do letter grade equals D. Okay. Now, if we check the average and it goes through every single test here, and all these tests evaluate to false, then the only other option, there's nothing else left. There's only A, B, C, and D, and then the only last letter is going to be else. It's going to be if, F. So that we call a trailing else or a dangling else. It usually goes at the end of this, and this is what's going to happen if no other condition is met, right? So the student doesn't have an A, they don't have a B, they don't have a C, they don't have a D, so the only other grade they could possibly have is going to be an F. So we'll go ahead and put that there. Okay. So we can go through a quick numeric example. Well, we'll do that in a little bit. Let's do the next part. The next part is the most important. It's going to be our output of the letter grade, right? Just because you determine the letter grade doesn't mean that you're actually outputting anything. Here we just assign the letter grade to the letter grade variable. So here we're going to do printf, and then we'll use a format specifier of, okay, so I'm going to do letter grade like this, and then I'm going to do %C for char, and then I'm going to do letter grade like this, and semicolon. Oh, don't forget your / n right here. Alright, so let's say the student's average is a 66. So then what's going to happen is we're going to go to line 33. Line 33 is going to check to see if the average, which is a 66, if 66 is greater than or equal to 90. If it is, it's going to display this, but in this case it's not. So it's just going to skip. It's going to jump from line 33 to line 37. Then it's going to check to see if the 66 is greater than or equal to 80. If it's not, then it's going to jump to the next one. Is 66 greater than or equal to 70? It's not. So then it's going to jump here. Is this 66 greater than or equal to 60? Yeah, that's true. So then it's going to, instead of skipping, it's going to go into line 47, and then it's going to assign the letter grade D, and then it will skip the last else. Right? So we already found the condition. Once it finds it, then it'll break out of this decision structure, out of this if statement, and then it'll go straight to line 56, and it'll print out the letter grade. All right. So let's go ahead and try it. So I'm going to do Control O, exit, and see if it compiles. I hope it does. Okay, so it seems to work good. So let's go ahead and run it. So we'll use our example of 66. So I'm going to set all the grades to 66. And, well, of course, the average comes out to 66. Tells them to try harder. It gives them a letter grade of D. All right, let's try another example. Okay, I'm going to go here. I'm going to do 100, 100, 100. Okay. So here they have all hundreds. They have a perfect average. They get the letter grade A. We'll try one more. Okay. So I'm going to do 20, 23, 25. So that's obviously an F. So it's going to go through every single condition. None of them are going to evaluate to true. So it's just going to do the last else. And it's just going to give us an F. So letter grade F. Right there. Okay. So just one more thing I wanted to show you real quick before we go. If you're having any trouble uploading your code to Blackboard or getting the file path, I just want to show you a real cool command real quick. It's going to be called real path, like this. And then you type your code, source.c, and then it'll give you the full file path of your file that you want to turn in. So in this case, always make sure you turn in the source.c file, and then here real path tells us that it's at this location. So if you do real path on yours, it'll give you your home, your username, and then everything else should probably be the same or similar. Alright, so I think that'll help a little bit. If you have any problems or have any questions, please email me. I'd be glad to help you. And I will see you in the next video. Thank you very much.